the third part of our alphanumeric database. In this part, we are going to still working with the website Lucidchart to create our entity relationship diagram and connect entities through their cardinality. Also, we are going to see how we can link two different entities through one entity that is going to act as a bridge. Some queries are going to be presented that are going to help us to make some math interpretations with our numbers. For example, average, higher than, between. And also we are going to see how we can extract specific years to make a more efficient search in our database.
Important note. In this tutorial, the database has been created with no real information. Fields like client name, phone numbers, project manager names, soil analysis, project numbers, concentration of chloride, benzene, etc. were chosen totally randomly or were invented. The only real thing is the legal land description. However, the areas were also taken randomly. The purpose of this tutorial is just education.
If you want to reproduce this database, feel free to email me nuska2003@gmail.com and I will deliver the data and queries by email.
Hello guys, and welcome back to my channel. At the first part, we was working at the website Lucidchart to create our entity relationship diagram. Also, we was working with software PostgreSQL, and we created our database and we introduced our first table. The entity for that table was client, and also we introduced all the data related with the attributes of this table. At the second part, we was working with the entity side. We introduced all the data related with the attributes of this entity, and we saw also what was the relation between these two tables and how we can combine the information between them. We make some queries to answer different questions. This third part, we are going to start to work with the table soils, and we are going to see also what is the relation between these two tables and how we can combine information between these three tables. Let's go to do it. I did already the table for the entity soils in Lucidchart, okay? As you can see, we have 1, 2, 3, 4, 5, 6, 7 different attributes for the soils. And the first attribute is the primary key, and this primary key is the ID analysis 1. And you can use the number that you can see at the analytical report from the lab, because the lab they use this kind of softwares, and the number they provide for the report, it used to be unique for every analysis they did, okay? The foreign key is the project number 2, and it's the same key as this one, okay? Here is the primary key, but passed to this table as a foreign key, okay? You have to keep different kind of names, as you can see here, project number 1, and here is project number 2, in order to avoid some errors with the database. It happens also here, ID client 1, ID client 2, okay? When you pass from the primary key to the foreign key, you have to change the name. That's a good habit. Also, we have the attribute for the entity soils, the sampling day, and some parameters, okay? Chlorides, sodium, sulfates, and benzene. And you can see the type of data is changing, okay? For that one is int in. For this one, the type of data, it's a date, because we are talking about dates here. and here we introduce a different kind of data type. It's a decimal number, and you can see here the number of decimals. Okay, 1 and for benzene, as the concentrations are lower, I decided to put 3 decimals. The link between these two tables is going to be the project number. Okay, as you can see, here is a primary key and here is a foreign key. And also now let's go to see what is the cardinality between these two tables. The analytical results for our soils, it's a very specific report for a unique site. When you get analytical results, it represents the results from one site. It doesn't make to have the results for a lot of sites. That one is going to be a mess, right? Then the relation between soils and sites, it's one to one. Okay, one soil analysis for one site. Now let's go to try to make the questions from site to soil. Okay, how in one specific site, how many soil analysis we can get? A lot, right? We can get many, because we can make a drill campaign in 2017 and we can make a different drill campaign in 2018, and we are going to have 2 different times where we drill the soil with different analytical reports, right? Then in this direction, the relation is 1 to many. Okay, one site can have many analytical results. Then the final relation between these two tables is 1 to many. Okay, like this one site can have many soils analysis, and one analysis soil can be just from one site. That's the cardinality between these two tables. Now let's go to see how we can introduce this information in our database. We know already how to do the estimate to create a table. I did already. I'm going to copy and paste here. That's the estimate for the table soil. As I said before, there are 7 different attributes, and you have the data here. Sorry, I didn't copy well. Okay, and the primary key is going to be ID analysis 1. Okay, let's go to run this query, and it's okay. Now let's go to create the foreign key. The estimate for the foreign key is this one. Copy, paste here. As you can see, the foreign key is going to be project number 2, is this attribute here, and it make the reference to the table site project number 1. Okay, table site is over here. Table site project number 1. Okay, it's the primary key at the table site. Let's go to run this one to alter the table soils, and that's okay. Now let's go here, let's go to refresh, and we have the table soil here. Let's go to make a select from soil, and we have all these fields. Okay, let's go to see the primary key and the constraints. As you can see, we have one foreign key and one primary key for this table. We can also see the primary key here at the columns. Okay, everything is good. Now I'm going to show you the data for this table. Is this one here. We have also 100 records for the analysis. We have the ID analysis here. As I said before, that's the number on the analytical report. This one is the project number. This one is the sampling day, and this one is the concentration of chlorides. If the value is less than 30, I put 1 decimal. Okay, I believe here is the same for sodium. For this one, if the value is lower than 20, I put 1 decimal. For benzene, I left 3 decimals. I put these parameters, but you can put whatever you think is interesting, okay? And these values could be anything, you know, the highest value, the lowest value, the average, whatever you want, okay? You can decide what parameters are important for you, for your projects, what kind of things you want to look for in your database, right? That is your decision. The person who creates the database has to look for information with the project managers in order to decide what kind of attributes they are going to use to make the tables. And finally, the goal is to create the most efficient database, right? The most easy way to find information in your database. Now I'm going to pass the information from the Excel to the database. Just copy all this data, go to Notepad, paste here, save as, soil. The encoding has to be this one, save, close this one. Go here to soils, right button, import export, select the file, remember that is text, soils, select, text, okay. And you can see here we have an error, okay. To see more details, we have the explanation here. Data time field value out of the range. What happened here? Let's go to see the table. This is day 13, month 10, and year 2017. Is this day here. The problem is the software didn't recognize that one as a date. It recognized that one as a month, and that's the problem. That's because the software say it's out of the range. Then we have to change the format. Just select all this one. Format cells. We have to go and date and change for this one, for example, okay? This one is year, month, and day. Okay? And now let's go to copy again. Copy. Go here. Soils. Select all this one. Okay, I'm going to create a new one. Delete, yes. Notepad. Paste, save as, soil, save, close, go this one, close this one, and I'm going to try again. Import export, test, soil, select, test. Okay, as you can see now it's good. We can close and we can see the table now. Run. And we have all the data here. As I said before, we have in total 101 records. Now let's go to see how we can change a specific value for a field. Okay, let's go to imagine that this concentration of chloride is not good and I want to update this number here. Okay, then the estimate for do that one is this one. Then we have to say update. The name of the table in this case is soil. Set. Now the name of the column is this one, chloride, and now the concentration. I'm going to say that is 10.5, for example. Where the ID analysis, because this number is unique, is this one. Now let's go to run this one. And the query returned successfully. And let's see if the result changed. Now it's not at the first position, goes to the last position. Is this one here, 23, 54, 67, 23, 54, 67, and now as you can see the concentration changed for 10.5. Okay, that is the way we can update a specific value for a column. Also, if you don't want to see number by number, you can make this search that is going to provide you a result directly. Select asterisk from soils, where ID analysis is this one here, this one, and that one is going to provide us just one result. Okay, now let's go to see a few questions for this table. Let's go to start. The first question is going to be how many sites have a concentration of chloride higher than 120 milligrams kilograms, and what are the projects. Let's go to copy here and put here. Okay, this is the question, and now I'm going to show you the query. There is a quite easy query, is this one. Select con, because we want to know how many sites. From project number 2 is this column here. From the table soil, where chloride is bigger than 120. Then let's go to run this one, and the answer is going to be 4 sites. We can write here 4, and now let's go to answer the second part of the question. Okay, now we know how many sites, and now we want to know what are the projects. Let's go to see it. In this case, the query is this one. Select, this is the columns. I'm going to show you the table soils. This is the second query to know what is the project numbers. Okay, select the columns. Is this column where we can see the project numbers and also the column for the concentration of chloride. From the table soils, where chloride is higher than 120. Let's go to run this one, and these ones are the projects. We have 4 projects where the concentration is higher than 120. I'm not going to write these ones here, but you can see the project numbers here. Okay, now let's go to the next question. The next question is how many sites have a concentration of benzene between 1 and 2 milligrams per kilogram. What are the projects? The difference between these two questions is here is higher than and here is between. Now let's go to see how we can see this one. Copy, paste, and I'm going to copy the query here. Okay, this is the query. Select con project number 2 from the table soils. This is the column, okay, where benzene between 1 and 4. It was 1 and 4, it was 1 and 2. Okay, it was 1 and 4. That's maybe more interesting, right? Okay, save. Let's go to run this one. And we have again 4 sides. So let's go here, number 4. Copy, paste, and now we want to see what is the project numbers, right? What are the projects? Then let's go to run this one here. Copy, paste. This one is the query. Okay, I'm going to show you the column, the table soils again. And for this one, we want to select project number 2 and benzene. This column here from the table soils is this one, where benzene between 1 and 4. Now we have the projects there and the concentrations. Let's go to the next question. What is the average concentration of benzene at the area located at the township 39, range 7 and meridian 5? Copy. Let's put the question here. Paste. And let's go to save all the queries we did. This one is the area where the township is 39, the range is 7, and the meridian is 5. Okay, now let's go to answer the question. In this case, the important thing is the average. Okay, in this case we have to use this command: select average from the column benzene, because we want the average concentration of benzene. I'm going to put the soy tables here. At this location. Then to do that one, there is 2 tables involved: site and soils, because as you can see here at the tables, at the soils we don't have the township, the range, and etc. Then we have to use the table soils because of the concentration of benzene, and also we have to use the table site because here we have the township, the range, and meridian. Then we have to combine these 2 tables to have the information, and that's what we did at the query. We connect the table site through the primary key and the foreign key. Here, this one, the primary key, site point project number 1, and here for this column here it's a foreign key. Okay, soils point project number 2. That's what we put here: site point project number 1 equal to soil point project number 2. Okay, then we put the location for the table site is this one. Now let's go to run this one, and this value is the average. As this table doesn't have a lot of records, we can check this result in order to test the quality of our database. Let's go to do it. To do that one, just we have to see how many projects we have in this area. We did the other day a pretty similar query for that question. How many projects we have at the area, then we are going to use the same query as we use for this to answer this question. It was this one. Okay, copy. Now paste here. Let's go to change the values. Meridian is 5, range is 7, and time sheet is 39. We have 8 different sites, but also I would like to see the concentration of benzene for every site. Then we have to add here benzene from site and from soil, because it happens the same. We don't have the concentration of benzene at the table site. Okay, the table site, the concentration of benzene is at the table soil. Then we have to link both tables. To do that one, we can use this one. Copy, because it's the same. Where and okay, let's go to see if it works. There we go. We have the concentrations, but now we have just seven projects. It means that one project that is here at the site, it's not here at the soils, because we don't have analytical result for one site. That site has to be 41, I believe, because the table finished before in 41. Let me double check. Okay, copy, paste, and we have to take this one out, this one out, and this one out, and let's go to run this one. You see 2018-141, it's not here. That is because we don't have the analysis for that project. Then in total we have 7 projects. Then I'm going to copy all these numbers and I'm going to do the average for the Excel. Is this one here? Here, average, and this one is the result. Let's go to compare this result with the result we get with the Postgres. It was this one. Run, copy, paste here, and as you can see, it's the same value. Okay, that is the way we can check if our database is working properly. Also, we can say that in this area the average of the benzene, it's let me double check, average is 1.93, and that's very nice because we can see exactly where our sites are according to this table. Looking for the LSD and the select, we have the exactly location of our sites on the map. and we can see what is the average for example, maybe this area here. Okay, then let's go to move to the next question. The average is this one. Oops. Copy. Paste here. And now if you see, the next question is the same as this one. The only thing is changing is the township, the range, and the meridian. But there is something very interesting in this question because of the number of the analysis. Copy, go here, paste the question, and let's go to see. The area is this area where we have a lot of oil and gas fields. Township is 93, range is 12, and meridian is 4. 93, 12, 4. And the other day we was answered this question related to that, the same location, okay? 93, 12, and 4. Then let's go to use the same query to see how many projects we have there. That we know is 36, right? But let's go to repeat this one. Is this one here? Copy and paste. Then let's go to run, and we have in total 36 different projects in that area. This query is from the table side. Now let's go to make a different search where we can see the project numbers and the date of sampling for the table soils. Where also we are going to combine the area with the township, range, and meridian. Then we are going to use both tables and we are going to combine the information. And we want to see the columns, project number, and the sampling day. But it's very important to see this number here because we have 36 projects there, right? But if we run this query, what happened is that we have 49. And how it's possible, right? Then the question is because in some sites we have more than one analysis. Okay, let's go to see. Okay, I'm going to order by project number. Copy, paste, and it's going to be more easy to see what projects are for different years. As you can see here, that one 2017-018, we have analytical results from 2017 and also for 2018. It happens the same for this project, for the number 20, the 21, the 22, 23, 4, 7, 30, and 31, 32, no, 36. No. There are some projects that we make the analytical results for 2 years. Okay, that is because we have 49 results in this table. Then we have to decide if we want the average concentration for the year 2017, 2018, or for the total. Okay, in this case I'm going to do the average concentration for 2018. Then I'm going to show you what is the query to just use the results from 2018. Okay, this one is the query. Select the columns project number 2 and sampling day from the table soils, and we are using the table side because of the meridian, the race, and the township. And also we want at the table soils just the projects for the year 2018, and that's the command for do that one. And extract year from sampling day, because we have the day here, equal to 2018, and order by project number. If we run this one, now we have only 13 results, and all these results are for the year 2018. Now let's go to calculate the average. The query for the average is this one. Paste, select average, benzene, because we want the average of benzene from the tables site and soils. And this one is the link, and this one is the area, and this one is the year. Okay, let's go to run this one, and it's going to provide us the average. The average for that 13 projects is 0.005. Okay, now I'm going to show you a query where we can see also the benzene concentrations for the projects on 2018. Is this query. Okay, we want to see these 3 columns in this area for the projects 2018. Let's go to run this one, and you can see the value here, 0.005. Okay, that is because all the concentrations are 0.005. Okay, that is because the average is 0.005, and we have 13 results in total. That query, it's a little bit complicated because it combines 2 tables. You have to take the 2017 results. There are a lot of things involved, right? But as more information you want to take from your tables, the more complicated is the query. Now let's go to answer the next question. For this one is 0.005, and the next question is this one. Copy, paste here, and the question is, what are the project number and the client names where the concentration of benzene is higher than 6 milligrams per kilogram? This one is the query, where we can see the project numbers and the concentration of benzene from the table soils where the benzene concentration is higher than 6. We have 3 project numbers where we have that concentration, but we have only what are the project numbers, and now we have to answer the client name. Okay, for the client name, in this case, as you can see, site doesn't have the name of the clients, soils doesn't have the name of the clients. The name of the clients can be found at the client table. Okay, but this table and this table are not linking. I'm going to show you the graphic. These 2 tables, client and soil, are not linking. Then we have to pass through this table to have the information on this table. Okay, we have to link the 3 tables. And how we can do that one? Okay, I'm going to show you the query for do that one. This one is the query where we link these 3 tables: soil, client, and site. Okay, and you have there the numbers, the names of the projects. The point here is how we can combine these 3 tables. I'm going to show you with the diagram. We want to know the name, that it's a field here in this table, but also we need the concentration of chloride that is in this table. and this table are not linked, but this table is linking with this one and this table is linked with this one. Then we have to pass through this table to have the name of the client and the chloride concentration and the benzene concentration. And that's what we did here. I'm going to use this one here to see. Okay, we use the primary key in this table and link with this table with the foreign key, as you can see here. Okay, client and site, this, and then we link this table with the foreign key here and the primary key here. That's what you can see in this second line. And that's the way we can combine the information between these three tables. Okay, even we are not using information from this table, we are using the primary key and the foreign key to link these two tables. Okay, that's it, guys. I believe the video is quite long and we are going to continue at the part 4. See you later, guys.
Yeah.